Alright, the first 5 of these questions, this is automotive electric test 5. Electric 2 test 5. A load of 325 amps for a 650 cold cranking amp battery is the correct load test amperage, and that is true. That is half of the cold cranking amp. What you're going to do there. Whenever you do load tests, what that means is, and we don't typically do that a lot out here, you know, but I've got that machine out there that you hook up to the battery. It's got a carbon pile in it, and what you're supposed to do is you're supposed to load it to half the cold cranking amps, and there's a 15-second light, a light that comes on for 15 seconds, and during that load test, it's not supposed to go down below 9.6 volts. If it does, the battery is either weak or it needs to be recharged or whatever. A good healthy battery will hold more than 9.6 volts at half of its rated cold cranking amp. But like I say, what I'm more interested in than that, I like to do an inductive test where I hook that little thing up and tells me how many cold cranking amps is in it. Because as you buy a battery to begin with, it's going to have, like, if it has 650 and you use it for a year, usually it'll have around 550 next year, and the year after that it'll have 450, and then it goes on down to the point to where it doesn't, it's like running out of gas. It doesn't have a whole lot of stuff in there. Number 2, an open circuit voltage in the 12.6 volt range indicates an overcharged battery. What's an open circuit voltage talking about? That's talking about when you're measuring a battery and there's nothing connected to it. You just take your battery cables off and you're going to check it just like that, right? So that's actually false. That's not an overcharged battery, it's just fine. Number 3, a 3-minute charge test can be used instead of a hydrometer to test a cell's state of charge. That's really not good either. You don't need to be doing that. One of the things that I teach in electrical 1 is we'll take a battery and we'll make sure you're supposed to basically charge it for 3 minutes and then let it settle out, and then you check the voltage of each cell by dipping the voltmeter in the water and going along there. In other words, you go from the positive post to the first water, you know, in the cell, and then you jump over and keep going over, and you're going to get 7 readings, and you're going to add the 2 readings on the end together. And basically what we're talking about, and some of you guys might remember that, you know, like if you got your 6 water holes in the battery, and then you got your 2 posts, you're going to get a reading here, you're going to get a reading there, you're going to get a reading there. You notice how you're just jumping over, you're getting readings from each pair, like that, like this, like that, and then you're going to get a reading like that. 1, 2, 3, 4, 5, 6, 7 readings. Now, you add this reading and that reading together. This is from your post to your first hole, and that is from your post to your other hole, your last hole. And on this one here, you're going to get a fraction of a reading. On that and there, you'll get another fraction of a reading. But the rest of them, they ought to be, like if this is 2.1, 2.1, 2.1, 1.8, 2.1, and then this is 0.5, and this is 1.6, you're going to add those 2 together to get you your 2.1. If there's more than 1/10 of a volt variance between any of those cells, you replace the battery. Now you're supposed to make there's 2 ways you're supposed to do this, and Sun came up with this, Sun equipment, you know, the people that make the big Sun scopes and all, Snap-on bought Sun. Okay, so you're sitting here and you're supposed to have big cables hooked up, and you're supposed to have it on charge each time you make one of these. You don't leave it on charge because your voltage is going to keep going up if you leave it on charge. So you really need a helper, right? So you hook it up and you turn it on charge long enough to get a reading, you turn it off. You move to the next one, you hook it up, you turn it on charge long enough to get a reading. You know, you can do it by yourself if you're industrious. And then you're also supposed to do it loaded the same way. Got me? You put it on there, you load it, you take your reading, unload it, put it on there. So you know, only while it's loaded. Now ideally, if you were a slick son of a gun, you would have a little thing with 7 little cheap voltmeters all hooked up at the same time, so that you could just check it all at once. You'd have to take some hooking up, but when you turned it on, you'd have all your readings right there. You got me? And if one of them's 1/10 of a volt off, you know, I mean, when I would go to and I'd tell them this vehicle needs a battery, you know, when I was kind of new in the field, but I had learned how to do this, they'd say, this needs a battery. And I'd say, how do you know? They'd say, how do you know? You know, and I'd say, that's before we had these inductive testers that tell you how many cold cranking amps it had. Because you can blame a battery when it's not a battery. It can be discharged, and you'll think a bad battery. And the most egregious offenders is the people on the car, the salesmen up there. You know, they don't want to pull the ignition off draw fuses out and everything, like what you have on some of the Chryslers and all. You're supposed to kill some of the circuits when the car's going to be sitting out there for 2 or 3 weeks. If they don't, that kills the battery. When they go out and test drive it, the battery's dead, they want you to throw a battery in it. Well, the problem is the battery ain't bad. It's just that it's been killed and it needs to be charged back up. Now, I've said this before, but I'll say it again. How many of you guys know that you can charge your battery up backwards? Yeah, you can actually, if you run it all the way down to where there's nothing in it, you can hook it up backwards to the battery charger and charge it up backwards.
But you got to turn the battery around with the negatives on the top?
Well, actually, see, what we used to have when I worked at that filling station, you know, 35 years ago, whenever it was, we'd come over here and we'd, you know, Farmer Brown would run his light, he'd leave his lights on or whatever, run the battery down. Then he'd take the thing off the truck and he'd carry it in there and put it in his garage. And it'd be so, I mean, completely dead. It wouldn't even burn up light. And then he'd hook it up to his battery charger without paying no mind to which post he was hooking up. And then he would turn on his trickle charger and he'd let it sit there all night. And then when he went to put it back in the truck and he went to put the battery cable back on, it'd be a big spark. Then he'd double check and he'd put it back on and it don't make a big spark. And then he had to bring it to the gas station over there and we'd hook a light bulb to it and run it all the way down. And then we'd charge it back up right. But you can hook them up backwards. I mean, you can charge them up backwards. Now, the thing about it, if there's anything in them at all, they're going to make a spark or a pop whenever you hook them up to the charger. But if they're completely dead, you can charge one up backwards. Did you know that, Webb? You knew that now, didn't you? I bet Matt Hussey hadn't even seen that. You need to ask him about that. All right. 3-minute charge test can be used instead of no, that's false. A 350 cold cranking out battery is specified as original equipment. A replacement battery should be 175 cold cranking amperes as a minimum. That's false. It needs to be at least as much as what they did it for. And the old rule of thumb, if you're basically just trying to get by, 1 cold cranking amp per cubic inch is the old rule of thumb from the old people that, you know, used to tinker around and, you know, wash batteries out and get them back up and then check them for cold cranking amp. If it had that, you know, there you go. So anyway, let's see. Regenerative braking is a method of capturing the vehicle's thermal energy in the batteries while it slows down. Well, that's false. There's not thermal energy you're capturing there. What you're basically doing when you do regenerative braking is you're whirling along here, and this little small, in most of these hybrid vehicles, you know, and I say most of them because you know, some of them are got slightly different designs now, but in the Toyotas and the Volvos and the Fords and all this stuff, you have a big motor and a little motor in there. And the little motor is actually the one that, the big motor is actually the one that regenerates and charges the battery. So when you hit the brake on that thing, it basically is going to take this motor that can drive the car and turn on some transistors and turn it into a generator all of a sudden. And like, you know, if I take this little motor right here, if I took that little motor right there, a little DC motor right there, and I spun it with a drill, you'd have voltage here. I could light a light bulb with that if I spun this with a drill, because it's got little permanent magnets in there. Well, those are basically AC current motors, you know, that works on, you know, 3 different wires going in, and it's, you know, got a resolver in there and all that kind of stuff. But these things right here, the electronics are set up so that it can actually change this thing into something that's going to create current using the momentum of the car to do it. Now, here's a word for the wise. If you're checking the brakes on a hybrid vehicle to see which ones are worn out, which brakes usually wear out the first on most vehicles? The front ones, right? Yeah. You're going to put 2 or 3 sets of front ones on for every 1 set of back ones you put on. Well, on hybrids, it's the other way around. The back ones are going to wear out first because the front ones are not going to be used as much as the back ones are on a hybrid because of the regenerative braking. And on some of these Ford Fusions, like you see drive that thing, you can look at a scan tool, and if you do a lot of stopping, you see that voltage go up to 650 volts. And that big battery in the back. You know. Anyway, let's see. Technician A says a 12.6 volt open circuit voltage reading indicates a fully charged battery. Technician B says a hydrometer reading of 1.265 indicates the battery cell has proper electrolyte specific gravity. Who's correct about that? C, isn't that interesting that 12.6 and 1.265 are similar numbers? All right, Technician A says the current capacity rating of a battery depends on the types of materials used in the construction of the battery. Technician B says the amount of electrical energy a battery is capable of producing depends on the size, weight, and active area of the plates. Both of those guys are right about that. You know, some of the batteries, you know, imagine that there's a lot of discussion that goes on across the parts counter about which is the best battery for my car. You know, because you got a bunch of different ones that are actually slated to go in that car. You can get this one for this much money, that one for that much, that one for that much. The battery that I put in my Taurus the other day was 100-month battery, I think, or something. It came from Ford. You know, it's a Silver Series battery and all that. Though they keep going up with the quality of the batteries that your dealership, you know, how long they'll guarantee them and all.
That's right. We keep going down on our batteries.
Yeah, that's interesting. But anyway, let's see. The battery of a vehicle has died 3 days in a row. Anybody ever had your vehicle battery die?
Yeah.
Each day, the customer was able to start the car after he charged the battery. He was then able to drive the car 150 miles, but the next morning the battery was again discharged. A battery current drain test revealed a 10 milliamp drain. Technician A says the current drain is excessive and it could be the source of the problem. Technician B says further testing is required, but it's possible the battery may need to be replaced. B, because 10 milliamps is not enough. More than 50 milliamps is too much, but 10 milliamps is not enough to worry. I'll tell you something else though. If you just check it and you get 10 milliamps, then you better be leaving that thing hooked up and walk away for a while and come back. Because sometimes on these newer cars with all these electronics, you may check it and find that you've only got 10 milliamps. But you know, you're checking it with your meter in series, right? You're going to get your meter here. And this is a cheap little meter. And you're going to take your meter right here. Well, you're going to check that, and you're going to put it on this amp reading right here. See that little amp reading where it says amps? You're going to turn it down there, and you're going to move this lead up here. Now, all of a sudden, you've turned this thing into an amp meter. And if you hook it up, if you take one of the battery terminals off, and you hook one of these leads to the battery post, and you hook the other one to the battery, the cable you took off, then every bit of the current that's flowing into that car, while everything's shut off and everything, is going to be flowing through this meter, and you're going to be able to read that parasitic drain. You got me? And it's going to tell you how much is there. If it's more than 50 milliamps, and it'll kill the battery, you know, usually in a couple of days, even if it's a good strong battery. All right, so just keep that in mind on that. But sometimes, and this guy right here is what he's talking about here, a battery can kill itself. A battery can have internal problems that can cause it to go dead by itself. Now let me ask you this. How would you verify? I would take the battery cable off and let it sit all night. You know what I mean? If I take the battery cable off and it sits all night, and I put it back on the next morning and it's dead, I know it's a battery, don't I? Nothing else it can be. If I take the battery cable off all night, and then I put it back on the next morning, it starts up, I know there's something in the car that's waking up in the middle of the night and killing it. Got me? Because things can wake up when you ain't looking. And I've seen that in the service bay. We'll sit here and we got one, we'll just leave, you know, meter or whatever hooked up to it, and it just walk away. And you come back 3 or 4 hours later, all of a sudden, you got a drain that wasn't there when you walked away. You understand what I'm saying? Those are the ones that are tricky to find.
Yeah, my town car, you could just be sitting all of a sudden and go,
Yeah. Well, something else that's kind of peculiar, some of these GM cars, they want to run the blower motor to dry the evaporator so it doesn't grow mold. So you'll walk away from that thing, and with certain temperatures and times are right and all that kind of stuff, you may walk by the car in your garage and hear the doggone blower motor running. Ooh, you know, and that's, I mean, I actually had the guy that used to be the president of the college when I first came here, he had a Cadillac that would do that. And I was trying to explain to him, look, that's the way this thing works. And he said he didn't understand, he couldn't understand what I was telling him. There's even a kit that you can put on other GM cars that General Motors puts out that's made to do that so that it will keep your evaporator dry, because when mold and mildew and stuff starts growing on your evaporator in the air conditioning system, it stinks. You know what I mean? So you want to get rid of that mold and stuff. And what Ford did, Ford actually made this chemical that you could spray in there to kill the stuff, but you had to wear a lot of breathing apparatus and all, or you should surely die breathing that stuff. But when you spray it in there, it was real poison, and of course it, when it dried out, is okay, but it would kill that mold and it would never come back again. All right, but anyway, let's see. Technician A says during a load test, the battery voltage must not fall below 9.6 volts. I said that a few minutes ago. Technician B says the load applied should be half the coal cranking out rating. Who's right about that? Both of them. Both those guys are right about that. Okay. Now, page 2. All right. Now, everybody knows you're supposed to put your name on your worksheets and tests and all and put them out there in the appropriate bin. She's got some laying up there, worksheets that were turned in without names on them. I don't know who those are.
I usually put Melissa's name on there.
All right. Oh, look at her. Okay. You know, you're talking to somebody and they're not paying attention, then you say, I pulled my pistol out and I shot him between the eyes. What? Who'd you shoot? You know, you weren't listening to me, were you? You're just trying to get his attention. At 80 degrees Fahrenheit, what's the correct specific gravity of an electrolyte in a fully charged battery?
1.265.
Wow, listen to that guy. He's been reading the book.
Yeah,
Foul. How many batteries be rated? Amp hours, coal cranking amps, reserve capacity, or any of the above?
Any of the above.
Any of the above is correct. And which of the following statements is not true of a replacement battery? You can either get what's in this box or what's behind door number 3. What's the answer to that one? A, it may have the same rating as the original battery. B, it may have a higher rating than the original battery. C, it may have a lower rating than the original battery. Or D, it should be selected according to the application chart.
C.
It may have a lower rating than the original battery. That's not true of a replacement battery. You're not supposed to have a lower rating. Back in the 1970s, in the late 70s, Ford was, when they would, you know, these big long Thunderbirds they used to make, and the ones, the LTD2s and all. Yeah. During those days, some bean counter decided they were going to put little anemic, stupid batteries in there that wasn't much bigger than a motorcycle battery. I don't know whose idea that was, but them little things were teeny tiny things. And everybody was making a joke of that. When you'd open it up, here's this little bitty battery, and the first thing people do is take that and throw it away and put a real battery in it. You know what I mean? And so, you know, their idea was, we were going to replace the battery anyway, so we only put that one there. How long can an automotive battery with coal cranking of 380 deliver 380 amps? 30 seconds at 0 degrees. 30 seconds at 0 degrees is how long it should be able to deliver 380 amps. Coal cranking amp of 380 amps is gutless nowadays. Because you usually got 1,000 coal cranking amps with 1,200 and all that stuff, you know. Battery electrolytes a mixture of water and what other element?
Hydrochloric acid.
Please. What is it? Sulfuric acid. Sulfuric acid. And you ever tell everybody that if you get that sulfuric acid on your blue jeans, that's the last you'll see of that place where it's splattered, right?
That cleans your hands pretty good.
Yeah, that's pretty good too. You're supposed to wear, really you're supposed to wear eye protection anytime you're working around a battery. You know, I'm telling you, just one time, you know, they'll be calling you Popeye if that thing blows up, you know. That ain't a good plan, man. You're supposed to have them batteries in there. That's why I have on these bulletproof glasses the other day. You know that the crazy thing about that Escort he's pulling the motor out of, it's been sitting there for 36 hours or something, and it hadn't been started or nothing. Key hadn't been switched on, battery been unhooked, and we're talking about unhooking the fuel lines. So I got the tool, and I went over here, and you know, if you've been sitting in a service bay with a motor part that we pulled out for a couple of days, we go to pull and Melissa and him were both sitting over. So I go to pull the fuel line off, and it fire hoses gas. I mean, just all over the place, man. You'd have thought somebody just... And of course, I had these glasses on. I didn't get it in my eyes, but they were traumatized. They were like, look at him. He got safety glasses on right now thinking about it. He popped them safety glasses on his face right here in the classroom. That was traumatic, wasn't it? It shook them up. They were like, ah. And also that stuff stings a little bit. That stuff will sting. It'll burn a little bit if it gets on your clothes and it stays on your skin for a while. Now, it's not the end of the world, and you shall not surely die, but it's unpleasant, you know. All right, so, all right, let me see, where are we at here? So, sulfuric acid is what it's got in there. Why does it need to be acid anyway? Why can't we just pour regular water in there? Hey there, Mr. Harrison. How nice of you to join us. Huh? What if you just put what's the pH level of water? What's the pH of water?
7.
7 is pH of water. What's the pH of battery acid?
3.
Wow, 1.0. So the pH of Coke is 2. Coca-Cola.
Oh, yeah.
So the pH of battery acid is 1 to 1.5. Okay, so you got to have an imbalance there. What if I take a lemon? Why is it that I can take a lemon? It's a pure old lemon you buy from the grocery store, and get a little weak light bulb, and you know, hook it to a couple of wires and poke them in that lemon. That light bulb lights up. There's acid in there, and so basically you got an imbalance. Those electrons like to flow. You see where I'm going? That's what that deal is. Now, what about alkaline batteries? What's up with that? It's got a higher pH than 7. It's still imbalanced. It's still unbalanced, isn't it? So the ones you got in your flashlight are alkaline. Then you got lithium. You know, there's other stuff going on like that. But anyway, I don't want to get into that too much. Which of the following is an indication of how well a battery should perform if the charging system vehicle failed? If the charging system of vehicle failed,
Reserve capacity.
yeah, you got basically, yeah, the reserve capacity is how long can it stay there? All right. And let me ask you this. Let's say that you're down in Key West, Florida, or Tampa or somewhere, and your alternator goes out, and you're down there, and you're actually talking, and the alternator is really hard to get to, and you don't really have the tools to change the alternator. Got me? And furthermore, when you go to the parts store or whatever, you're going to find out the alternators on that car is $300.
What car?
Yeah, so what you going to do? Whatever car you're driving. Let's say whatever car you're driving. All right. You also know that when you get back home, you got another alternator laying there that you bought years ago that somebody got that they didn't need. They gave you that you know is a good one still in the box. All right, you're down in Tampa, and this other alternator's at home. You need to get back home, so how you going to do it? Your alternator's down for the count now.
You're going to drive as fast as you can to get there in 30 minutes.
No, what you do is, I'm going to buy me a really strong battery. That's what I'm going to do. You know what I mean? Heck, you can buy a trickle charger usually for 30 or 40 bucks. All right? So you buy a good strong battery and a trickle charger, and it may take you a couple of jumps to get home. You know, you have to stop on the way home charging batteries up. But you can make it home driving on the battery if you don't run the air conditioner to the lights, you know, and all this kind of stuff. You know, you can usually go pretty good ways on it. You get a good strong battery to put in there. Now that's kind of a dumb question, you know, basically. But my brother wound up in that set of circumstances. He asked me to do an inspection on his car. And he said, look at my car over and see if it'll make a trip to Key West and back. So I looked it over, and I didn't see anything that, you know, flagged that I could see. Everything was good. The belts were tight. It had good coolant in it. Wasn't leaking oil. Running smooth. All that kind of, what are you going to do? I mean, you check it as good as you know how to check it. Well, he gets way off down there in the Keys, and his doggone alternator goes out. And he wants to blame that on me. How can I look at an alternator and tell it's getting ready to go out? Unless I tear it down and look at the condition of the brushes or something, and then it could still go out some other kind of way, you know. He got a little huffy, but, you know, since he's my brother, I just slap a taste out his mouth. Anyway, let me see here. Let's see. What is, how many volts can each cell of an automotive battery produce?
2.1.
Yeah. No, 2.1 actually is the right answer on that. Because think about what you got. 6 cells, you got 2.1. That's 12.6, isn't it? Yeah. It's on the board? Yeah, 2.1.
Oh, I didn't know that.
Yeah, I wrote 2.1 up there. Yep. Right up here, see? I wrote that. Let me see. What's the principal cause of battery water loss? What's the principal cause of battery water loss? Evaporation due to heat of the charging current. Let me ask you this. Where does that stuff come from that chalks up the battery terminals? Well, that's what you call it, but where does it come from? What's the source of it? And why is it that you open the vehicle, you open the hood on some vehicles, and even if they got some high mount, you don't see none. They'll have the original battery terminals, there's no corrosion there. And you open some other ones up, and some of them are all chalked up and ugly. You know, they got that neat little cover that's supposed to keep them from shorting out, and it hides all that stuff. And when you pop it open, it's like, no, alien critter in there. You got all this fuzzy green stuff all over it, you know. You hear where I'm going with that? I mean, it looks terrible when you open it up. So why is it that some of them chalk up so bad with that junk, and some of them don't? I want mine to not do that. Where does it come from? That's what I want. What's the source of it?
Don't you put water in some, but others you don't?
Well, they all got it in them, pretty much, unless they're a gel battery. But yeah, but now, what you're talking about, I mean, what I'm saying is, how does that stuff make it to the posts?
The heat and evaporation.
Negative terminal usually, isn't it?
No, the positive one usually is the one that I see it. I mean, it can do either one of them. But the positive one's usually, which one you usually see? That's dirty. Like that picture up there. See that picture up there with that filthy battery terminal?
Oh, mine be like that.
Yeah. you done dissed your battery. Your battery's on the disk list. All right, so here's what I'm going to tell you. My contention is, do you know where that lead post goes through that plastic top of that battery? It comes through there, around that, between the lead and the plastic. Wear sweat. And that's why those little felt washers are a good idea. Yeah. However, they're not 100%. But now what I used to do when I was working at the dealership, if I was putting a battery on there. Now to begin with, when I put a battery on, what happens when you change a battery? You probably changed quite a few batteries over where you're at. You pull them out of the darn old battery box, a little rusty and all this kind of junk. Well, what I do is I'd, put me on some, something to, maybe a shop rag around my nose where I look like a, stagecoach robber, and put some safety glasses on, and I'd clean that battery tray up with a wire brush, and I would keep me some primer there, and I'd prime that thing black. Make it real pretty, and then I'd put it all back together. And if a customer happened to be hanging around watching you do that, he goes, man, this guy's really going the extra mile. Instead of just throwing a battery in there, he's making everything nice again. But I would also put some dielectric grease around that seam, like the tune-up grease we use, the WA10 Motorcraft stuff, if you want to use the part number. Smear it around that terminal and put it back on. That will mitigate that somewhat. Also, using that battery terminal protector helps keep it from bonding to that stuff, If it's got battery posts on there, the old terminals with the bolts going through the side of them, I like to knock those out, put new ones in there, and put them nice, and then, clean out that little place. And I'm kind of OCD about battery terminals. I like to make them, really good. Our shop foreman was too. He would rather give the person a free battery terminal cleaning than have it leave his service bay looking like that. You got me? But it takes some work to do it. Okay. Let me see here. Let me go down here.
18.
Let's remember that. That's 18. When using a battery starter tester to make a battery load test, turn the control knob to draw battery current at a rate equal to which of the following? Half of the battery is cold cranking out. So we already covered that. Let me say one more thing about this battery corrosion stuff. Sometimes the evaporation will actually transfer some of that acid to the top of the battery. If there's enough of that junk on the top of the battery, surface drain can carry power from one post to the other and kill that battery just because the stuff's on top of the battery. You know what I saw on top of a battery one time that killed it dead as a hammer? A big mountain of ants. Ants got up there, and they shorted out their little electrical communication or something, and there was a mountain, a trail of ants, probably a quarter of an inch thick, that was leading from one battery terminal to the other.
Wow.
So a battery went down on my Thunderbird, and it comes in on the hook. I open it up, and I see all those ants on top of the battery. Well, that's what's wrong with it. Right there. You don't have to look all that far.
They shorted
Clean all that. The ants shorted. The body's little ants shorted it out. And they like electrical stuff. How many of you guys ever been in the country where you got a pump pumping out of a well, and you got a regulator, and the darn ants get in the regulator, and they, well, my dad took some bleach one time out there at that house where he was at, that sawmill house where he's at, and he splashed some bleach on it to wash them ants off there, and that bleach caught fire and burned up his regulator. He said, I didn't know bleach would burn. And he destroyed his regulator with it. So he was laughing about that. Okay, we've been here 27 minutes and some change, so let's keep moving. Let's see, how much of a change in specific gravity? Wait a minute. Yeah. 19. At the end of a 3-minute charge test, the voltage reading for a satisfactory 12-volt battery should not exceed how many volts? The voltage reading. Now, let me know what's this. We're actually got our battery charger connected, and we've got that son of a gun charging on like a medium charge, maybe 40 amps or something like that. And we're going to watch the voltage on that battery while this thing's charging, right? We're going to leave the charger on it. We have our voltmeter hooked up. That voltmeter should not go over 15.5 volts. If it goes over 15.5 volts, that is a sulfated battery, and it is of no account. Everybody got that?
It's a lying.
That's why your battery chargers, some of them have got, at that 15.5 volt range, they've got a red zone. And if you're charging it and you're looking at the gauge on that one, Midtronics charger we got out there, you're going to see it going to the red. And that means you got a bad battery, okay? And so when you see that, listen guys, that's a go, no-go test. If it goes over 15.5 volts, you're done with that battery. Then you need to fix that. Got me? Now some people say, well, when you charge it, you heat it up and you'll break some of the sulfur off, and and it falls off in there and all that kind of stuff.
Yeah,
all right.
somebody told me one time if you
I don't know what they were drinking, but they haven't been drinking battery acid. Remember when I was cleaning that lady's battery terminals out there in that parking lot, and I asked her if she had any Coke, and she asked me if I was talking about pop. Remember that story?
I remember that.
Yeah. I said, you got some Coke? She goes, what do you mean, soda pop? What else? What else would I meant? You know, I wanted soda. I wanted Coca-Cola. A technician A says a fully charged battery will not freeze as easily as a discharged one. Technician B says the specific gravity of a fully discharged battery.
Where you at?
What did I do? Did I jump over a question? I apologize. How much of a change in specific gravity readings does the temperature compensation allow for every 10 degrees? That's number 20. That's A. That is 0.004, if you want to say it that way. All right, technician A says a fully charged battery will not freeze as easily as a discharged one. Technician B says the specific gravity of a fully discharged battery is around 1.100. What you got on that?
A.
That's actually going to be C. That is a C. Why should specific gravity readings be temperature compensated? A, they're a more accurate indicator of the actual state of charge. If you temperature compensate your battery or, you know, your specific gravity readings, you're going to get a more accurate indicator of the actual state of charge. Now, I will tell you this. Let me ask you this. Somebody says, my battery's dead, the car don't start, and you take a really good, strong battery charger like this one we got out here, and you hook it up, and you try to start the car, you know, you turn it on high charge, you try to start the car, and it goes, What does that mean? Battery's bad. Typically means you need a battery. You put another battery in it, you'll be good to go. But I mean, every time you ever see that, you know, that charger, if that battery will hold anything at all, one of those big chargers, as soon as you hook it up and put it on boost, it ought to fire up. Now, sometimes jumping a car off, even if you got really good looking battery jumper cables, you got to make doggone sure you got a really good connection on that kind of thing. Because sometimes jumper cables, sorry set of jumper cables can look like a good set of jumper cables. That makes sense? You can have a set that looks like a good set of jumper cables, but they're really not adequate. And people will argue with you about that until you hook the jumper cables up, they get the car started. Like the ones I carry in the back of my truck. And when I pick them up, I got to go put them on my shoulder. Go over and hook those things up. They're huge. I mean, they're big, thick, you know, wire. But when I hook them up, I don't care if it's a diesel tractor or whatever, it's going to bust off, you know, if there's anything there that's not a bad starter. Or loose voltage, whatever, voltage drop. Why should specific limit, never mind, I got that one already. Which of the following statements is true about nickel metal hydride, which is not true? Which of the following statements about NIMH battery cells is not true? A, when an NIMH cell discharges, hydrogen moves from the anode to the cathode electrode. B, nickel metal hydride batteries have an anode electrode that contains nickel hydroxide. C, the alkaline electrolyte has no active role in the chemical reaction. And D, the plates are separated by a sheet of fine fiber saturated with potassium hydroxide. Now, that's a no-brainer. Everybody should know the answer to that. That's B, nickel metal hydride batteries have an anode electrode that contains nickel hydroxide.
Okay.
Remember that. Now, that's going to be on a pop test one of these days.
Okay.
Which of the following statements about battery ratings is true? Okay, this is going to take a lot of reading here, but I can read. Can you all read? Basically, C is the one. It's true. The cranking amperage rating expresses the number of amperes a battery can deliver at 32 degrees Fahrenheit or 0 degrees Celsius for 30 seconds and maintain at least 1.2 volts per cell. See, a lot of people have studied this. Okay, technician A says the best way to charge the high voltage battery is by allowing the engine to run. And we're talking hybrid vehicles here, got me? When we're talking about a high voltage battery. Technician B says usually an onboard jump assist method is available to start the engine if the HV battery state of charge is low. That's what SOC is. Both those guys are right. However, that is really a silly question because on some of your earlier Toyotas, you had no way to charge that battery. You know, got me? Talking about the if the high voltage battery was low, the earlier Toyotas back in the mid-00s, you would have to get a special battery charger shipped over from Japan to charge that darn thing up. And they would just lease it to the dealership long enough to charge it up. They wouldn't let you keep it. But now on the Ford Escape, you had a little button you could push, and you could push that button, and it would use the 12-volt battery under the hood, and it would run it through the electronics, and it would start putting power back in that big battery, and you could do that 2 or 3 times, and you'd have enough to go. That's really the way it ought to be. Which test is being performed in the figure below? Which test is being performed in the figure below, in that particular figure right there? Anybody see that? What do you think? That's number 26, right? See what we're doing here?
Which car test?
Charging.
Sale too?
Yeah, what test is being performed? Voltage drop test across the battery terminal connection. Now that's a sort of a crazy picture, don't you think?
Yes.
Isn't that a crazy picture? How am I supposed to look at that and tell that's what they're doing? And if you guys didn't get that right, I think I would probably be a little bit confused there too. Got me? So I'm not gonna penalize you too heavy if you missed that one, although I did tell you the answer. Now then, these right here are short answer questions. Don't you love short answer questions? I think I'm gonna put at least 20 short answer questions on your final exam. That would be good, wouldn't it?
Oh my God.
Yeah. Listen to everybody complaining over there. Somebody said that sucks. Somebody says, oh my, or whatever. So that means I need to put half of them be short answer. Okay. Name the 4 types of battery capacity ratings. The 4 types. You got amp hour, cold crank, and reserve capacity and cranking amps. You got those? That's a good thing, isn't it? Did you feel like you got the shaft? All right, let's look at 28. What effect does corrosion on battery terminals have on the battery output? Duh. It lowers battery output and efficiency. We need a good, strong battery. We need good, clean terminals. If we don't have a good, strong battery and good, clean terminals, we ain't really going to have what we need to get going on it. Now, let me tell you something else, guys. This is really important, too. I've seen cars quit going down the road because of dirty battery terminal connections. Can you swear they had some other kind of problem? Just plumb quit going down the highway. All right, number 28. Let me see, number 29, I'm sorry. What type of energy conversion occurs when a battery is discharging? Short answer questions. If you don't have a bunch of A, B, C, and D, you're wrong. Chemical energy is converted to electrical energy. This is the way tests used to be back when they only went to the 8th grade during the founding era, and people actually had to, you know, if you didn't graduate whenever you were 14, you had to just keep going to school until you were done, basically. Yeah, they did. You know, you might graduate when you were 26, but you're going to finish the 8th grade before you're done. And the 8th grade as far as it went, you know, in those days. And
I finished 6th grade twice.
Yeah, cool. All right. Let's see. So 29 is chemical energy is converted to electrical energy. And 30, what term is used to describe electrical loads that are still present after the ignition switch is in the off position? What do you call those? Parasitic loads. In other words, loads that are just going to leaching off the battery and going to kill it all. What rating indicates the battery's ability to deliver a specified amount of current and start an engine at low ambient temperatures? Cold cranking amp. There you go. Give that man a cigar. What rating indicates the battery's ability to deliver a specified amount of current and start an engine at low ambient temperatures? I already asked you that one, didn't I? Now, why did I read it again? That was dumb. What's the makeup of the electrolyte solution used in automotive batteries? How much of it is water and how much of it is sulfuric acid? Anybody know that?
90 and 10?
No, it's 64% water and 36% sulfuric acid. Some of the old timers, if they felt like their sulfuric acid level in their battery was getting low, they put aspirin in it. Well, it's acid, you know.
What was the 36% for?
36% sulfuric acid, 64% water. You gotta have a photogenic memory in here, don't you? Or photographic. You ever take a picture of somebody's memory? Okay. Now then, 33. What's the specific gravity of a battery at 80 degrees Fahrenheit?
1.264.
Close. 1.265. He was only a tiny bit off there. Number 34. What's the process of discharging the battery almost completely before recharging it? What do you call that?
Discharging the battery?
Well, a deep cycle. A battery that you use in a trolling motor on a boat is called a deep cycle battery, and that means you can run it down and charge it up as many times as you want to, and it's okay. On a car battery, like the ones on our trainer cars, they're always going bad because we run them down and charge them up and run them down and charge them up, and that ruins the battery over time. It just destroys it. I mean, if it's not a deep cycle battery, it doesn't like that. Okay?
In other words, we need new batteries on all the cars.
No. That's easy for you to say. You're not the one paying the bill. You know what I'm saying? And this is the same guy that came over here and says, we need some more tools because I can't find a 13 millimeter socket. What do you want me to do? Buy a bunch of, I don't have a GPS on these things. I'm not the one that pull them out of the door and throw them all over the shop, you know. And you know, when I accost everybody about why the tools are always missing, every single person there says, well, I always put them back. Well, there must be a ghost. Or that person called not me that runs around here. Okay, let me see. Describe the need for a 42 volt system. Well, really. I mean, this is a sort of an old question. This is a new textbook, but it's an old question. Due to increased electrical and electronic systems and increased wiring, higher voltage will support the use of more electrically operated devices such as power steering and air conditioning compressors, yet reducing fuel consumption. Higher voltage decreases the need for larger wire harnesses. What happens when you got more voltage? What happens to amps when you got more voltage?
It goes up.
It goes down. You got higher voltage, you got fewer amps. Got me? Remember what I always telling about, if I'm going to put a window unit in the classroom to help cool the classroom, and I want to get a 10,000 BTU window unit, right? Okay, if I get one that's 110, and it's going to pull 30 amps, and that's going to run my power bill up pretty strong in it. If I get a 220, it's only going to pull 15. The more voltage, less amps. You're going to cut your amps in half. If you double your voltage, you half your amps when it comes to doing work. Okay, you got that? Whenever my dad had this bug shop, Volkswagen bug shop, and in 1967, I think it was, Volkswagen stopped, they got away from 6-volt systems and went to 12-volt systems on their car. Now, American cars changed in 55, I think, a long years before that. But the Volkswagen was 6-volt for a very long time. But you could take and change the voltage regulator and the generator and change that car over to a 12-volt system. The only thing that you couldn't swap out was the starter. Because the starter is different. A 12-volt starter was different from a 6-volt starter. But it didn't matter. You could use the 6-volt starter, that 12 volts, to just spin that thing out of there, man. Just start the crud out of it. And it didn't hurt a doggone thing. It seems like it would, but it didn't. List the major reasons for battery failure.
Operator error.
Operator error. You ever operated a battery? Come on now. Okay. 1, cracked case. You ever seen a cracked case?
Yes.
2, improper electrolyte level. 3, corroded terminals. 4, overcharging. 5, undercharging, which is sulfation. Sulfur coats the plates, and that actually is, you can troubleshoot that by if the voltage goes up too high while you're charging it. Excessive vibration, poor hold downs. Like if you see these batteries, and I'm sure you see them out there at the parts store, they're just dancing around loose in there because the hold down's gone.
One had a bungee cord holding it down.
Yeah, that holds it down. During normal battery operation, the active materials on the plates will shed. The negative battery plate also becomes soft. Both of these events will reduce the effectiveness.
Yeah, those are gone, Rich.
What?
We don't have those.
I don't have that one.
No, this is actually one of the reasons it fails.
Oh. No,
During the normal battery operation, the active materials on the plates will shed. The negative plate also becomes soft. Both of these events will reduce the effectiveness of the battery. Now, let me hit you with this. You got a battery. I used to see this when I was working on heavy equipment. I would see this. You got a battery, and whenever you got a lot of current flow into these old big, 40 MT Delco starters and all that kind of junk, your battery posts start out looking like this. Well, sometimes you have a bad connection. Big, strong, powerful battery now. This is an expensive battery too. Bad connection there. All of a sudden, it goes, and it has burned this battery off to a nub. That's bad news, man. We got an expensive battery here. We need to bring that thing back online. How you gonna do that? Hold on, you got to make it happen, man. You're the heavy equipment guy. You're the guy that's got to make this thing going. You got to be the problem solver. I don't care if you're only 21 years old. I'm paying you good money. I expect this straightened out. You need to come up with some way to do it. Hey, we're going to have to replace the battery. That's unacceptable, man. There's nothing wrong with this battery. So the post is burned off. You know how much a battery costs? The guy that I work for, he was tight. He paid good, but he was tight. Okay, so I came up with a way to fix that.
Solder.
Crap out of it.
A lot of solder.
A lot of solder.
What you do, JB with it?
JB weld is not good because they're not going to connect power. Okay, what I did was I would put a fairly large screw in there. Wait a minute now. Either tap it or just let it bite in, you know what I'm saying? And then I built this little mold. It was just the right size and it was tapered and all. I built it there was a piece of stainless steel stock that had a hole through it, and I drove a tapered punch up through it, tapered it a little bit. And then I would set that little mold on top of that. And then I would take a little, one of them solder on battery terminals, and I'd fill it up with solder, and I'd pour it in there. Just pour that solder in there, Of course, you got to use a bowl that the solder will stick to. And you can fill that thing up. You know, and when that solder cooled off, you know, it had bonded with that lead and with that bolt. And then you can take your little, you know, your little cone-shaped mold off, and you done put a new battery post on there.
See, there you go.
You probably won't ever have to do that, you know. But occasionally somebody will get too aggressive trying to twist the battery terminals to pull them off, and all of a sudden they broke the battery terminal off even with the top of the battery, and oh, this battery is only 2 months old, you know. See what I'm saying? Anyway, the killer was I had to have that little piece of stainless steel mold that I made, you know, to do that. It would handle the heat, and it didn't stick to the solder. You got me? So it was just right for that. But I mean, I just actually made another battery post. Now you don't heat it with a torch here and pour the stuff in there. You know why that's a bad idea? Because you can get a boom. But if you've got some molten solder in a little cauldron of some kind that you heat it over here, and you can carry it over and pour it because there's no open flame, seeing there's no sparks, so you're not going to have an exploding battery that way. That's a kind of an unorthodox way to fix something, but basically it's not a perfect world, and you've got to come up with some kind of way to do stuff. Let me tell you one more thing. If you're not the person that they don't want to get rid of when it comes time to get rid of people, then you'll get laid off. But you want to be the kind of person that when they look at him and say, we can't get by without him. Now, you can lay these other guys off, but this guy stays, because I cannot run this shop without him. He's the guy that I'm going to keep.
Yes.
Of course, if you're the guy that's the water cooler warthog and you're standing around and you're not getting any work done and you're not turning any hours every week because you really ain't very ambitious, they're going to say, this guy's dead wood. We just need to send him packing looking for another job somewhere. You know, so just keep that in mind. You're going to be the guy that's their problem solver, their troubleshooter, the guy that can do what other people can't. You know, if you can do what other mechanics can't, that's good too. If you can do what other people can't, you can get a job. If you can do what other mechanics can't, you can keep your job. A lot of times, even whenever times get bad and all that. Of course, they don't usually lay mechanics off anyway, you know what I'm saying? You know, welders get laid off, mechanics don't, usually, with all due respect to welders. Because you got lots of welders, and all of them can do about the same thing, you know what I'm saying? Anyway, that pretty well ends our